going to begin talking about trends on the periodic table. And the three trends that we're going to look at are going to be atomic radius, ionization energy, and electronegativity. A trend is really just a pattern. This video will cover atomic radius. You should have a note page that goes along with this PowerPoint. So again, a trend is just a pattern that we see on the periodic table. We've already seen one pattern with those valence electrons, and also seen a pattern with the oxidation number, the charges of the ions. So these trends, these patterns that we're seeing are because of the electron configuration. And again, this video is going to cover atomic radius. So if you think of a radius as a circle from the distance from the center to the out, the atomic radius of an atom basically is the size of the atom from the nucleus all the way out to the outermost energy level. That is the definition of atomic radius, distance from the nucleus to the outermost energy level. And we see a pattern. And so as you're looking at a family or group, so families go up and down. So as you go down a group, family or group, the atoms are going to get larger. So as you go down on the periodic table, and the reason that is, as you go down, we're looking at lithium, and I'm looking at a Bohr model just because it makes it a little easier for us to see. Lithium has two energy levels. It has two electrons in that first energy level and only one in that second energy level. But if I were looking at sodium, it still has a valence of 1, but it has added another energy level. So the distance from the center out is going to be greater for the sodium atom. So as you move down, it does get larger. That makes perfect sense, hopefully, to you. And so as we look at a periodic table, we says as we move down a group, remember as you move up and down, these are called groups or families. And so it is going to increase as you go down, so that sodium is going to be a larger atom than that lithium. And that is because you have more energy levels. Remember, this period number here tells us how many energy levels it has. And so right now, 7 is the most that we have. So what if we were comparing a sodium atom and a chlorine atom? So number 11 and number 17. Our brain would make us want to think that number 17 is larger, but actually number 17 is not larger. It is actually a more dense atom. And so let's look at that. Sodium atom is actually larger than the chlorine atom. So as we go this way, and this is known as a period, as we move to the left on a period, we're going to see that the atom gets larger. So I don't know if you can see the bottom of the screen, but we've got a sodium atom here. And again, I'm looking at the Bohr model. And so there are three energy levels. So 3 energy levels from the center. And so chlorine also has 3 energy levels, and right now I've got them depicted as the same size. But I want to concentrate on the number of protons. Protons have a positive charge, and electrons, which are in these outer energy levels, have a negative charge. So this one has 11 protons pulling these 3, we'll say, rings in. So like 11 magnets pulling in these 3 energy levels. This has 17 pulling in. So chlorine actually becomes more dense or a smaller atom. So the sodium atom is larger because it doesn't pull these rings in as tight. All right, so atoms are larger as you move left in a period. Remember, as you go left and right, that's known as a period. So on the left side is larger. And this, the reason is because they have the same number period, which means they're on the same row, and they have the same number of energy levels. And as you move to the right, so over here where chlorine is on the periodic table, there are more protons, and those protons are pulling in, making it a more dense atom. So down is larger and left is larger for atomic radius. So if I were to give you, let's just do an example of maybe an iodine versus a lithium, and I said down into the left. Okay, so which one is larger? So I've got one to the far left and one far down. So what's more important? What's going to be more important is the energy levels. Iodine has 5 energy levels, and then lithium only has 2. So this rule is more important than the left-right. The left-right rule, which means it's larger this way, is only if it's on the same period. Okay, so only if it's sitting on the same period would we need to care about the left-right rule. Okay, so this just depicts increasing size down and to the left. That's just showing the overall trend. There is always going to be some exceptions to this, but for the most part. So atomic radius increases. So we've got francium here being our largest atom. So what happens if it's not an atom but yet an ion? So we formed 2 different types of ions. And so one type of ion was a cation. And a cation, we remove electrons. So if you remove electrons, the atom actually gets smaller, and the reason is it's actually pulling those in tighter. We can actually see the configuration as well. If we wrote out the electron configuration for just a sodium atom, 1s2, 2s2, 2p6, 3s1, that's the atom. Well, how does it become a positive 1? 1s2, 2s2, 2p6. We've taken that 3s1 completely off. So this only has 2 energy levels, so it gets smaller. So cations are always smaller than the original atom. You can see here we measure it in picometers is what we measure it in, and you can see it's almost half the size. It's crazy how much difference that one little electron will make. So then what if you get an anion? So what about an anion? Anion has gained electrons. So when it gains electrons, there's less pull to the middle. So it actually gets larger. So when it gains electrons, it gets larger. When it loses electron, it gets smaller, the size of the electron cloud. And so the next slide just kind of gives you an idea. You can see the peach. That is the original atom, and the blue ones are cations, and the green ones here are anions, and these are picometers that you're seeing. So you can see the overall trend is the negative ones get larger, and the cations positive get smaller.